So, what are the assumptions of classical physics? We'll look here at two theorists who've examined this topic. The physicist Amit Goswami and the science writer David Hodgson. Their lists of assumptions can be divided into two basic groups. Firstly, what can be called the mode of existence of physical objects, and second, the nature and effect of observation and measurement. Goswami talks about the perspective of strong objectivism. This asserts that objects are out there and that mind and consciousness play no role in creating them. Hodgson identifies three assumptions classical physics makes about physical objects and their motion. Firstly, that all physical objects, regardless of size, exist continuously over time, though they can change. Second, that objects exist independently of being observed or interacted with. Thirdly, objects have, at any particular time, definite dimensions and mass, a definite mechanical state, including location and orientation, and a measurable motion in terms of both velocity and rotation. Fourthly, motion is continuous over time and infinitely divisible. In other words, a definite position in space and a definite motion can be identified for all objects. All this is consistent with common sense, but has, over the last 100 years, been challenged by the new physics. The assumptions on dimension and mass are challenged by relativity theory, and all the rest are flatly contradicted by quantum theory and have indeed been abandoned, at least at the microscale of atoms and particles. Classical physics also adheres to the principle of locality, meaning that there can be no simultaneous causal action at a distance. Again, this is contradicted by quantum theory, with its conceptions of entanglement, tunneling, etc. Classical physics assumes the doctrine of materialist monism. This states that matter is the only form of existence. There is no other substance or realm. The world is composed of objects arranged in a huge variety of combinations and states, and again, all this is entirely independent of mind and consciousness. As regards observation or measurement, classical physics takes the position that, while it may not be possible to be absolutely accurate in practice, there are no theoretical limits on the accuracy of either observation or measurement. Thus, in the classical view, there are no theoretical limits as to the smallness of any disturbance in observation or measurement, or on the accuracy with which any such disturbance can be measured. And in any case, any imprecision in observation or measurement does not mean that an object's actual position and or motion is itself uncertain or imprecise. Classical physics incorporates Newton's conceptions of materialism and causal determinism. These state that all events are embedded in endless causal chains, ultimately leading to the concept of the total physical closure of the entire universe. A corollary of this view is that there are no gaps in these causal chains in which non-material forces, such as Descartes' conception of mind and consciousness, might intervene as causes. Hodgson and others have identified the ideas of the French 18th century mathematician Pierre Laplace as the most thoroughgoing expression of mechanism and determinism. According to Laplace, the entire universe, including human brains, consists of a few kinds of basic objects moving through space in accordance with Newton's laws of motion, end quote. This results in total predictability. If an observer knows the initial conditions, i.e., the position and motion of an object at any instant of time, and all the forces acting on it between that time and any earlier or later time, then this observer can calculate its position and motion at any earlier or later time. As Hodgson puts it, quote, "The position and motion of objects and the magnitude and direction of forces can be represented as quantities, numbers of various units of distance, rotation, velocity, mass, acceleration, etc., to which purely quantitative mathematical laws can be applied to give precise results representing other positions and or motions of objects," end quote. Laplace concluded that any being who knows the relevant laws and state of the universe at any one time will be able to calculate the state of the universe at any other time. Such knowledge and calculations may be beyond the capacity of any human being, but as Laplace pointed out, God should certainly be capable of achieving this level of predictive power.